Different forms of logarithms and evaluating logarithms. Contents. Welcome to this presentation on different forms of logarithms and how to evaluate logarithms. We, we cover key logarithmic forms and discussions on how to solve logarithmic equations with examples. This is a key concept in understanding exponential, exponential growth and decay. Introducing to logarithms. A logarithm is the inverse of an exponential function, and the logarithm of a number is the exponent to which a base must be raised to obtain that number. For example, logarithm helps determine the exponent needed to reach specific values with a given base. A key logarithm forms. Common logarithms often used with a base of 10. Natural logarithms then use a base of e, which is a mathematical consistent. General logarithms are logarithms with any positive base except one used in various contexts. Logarithmic rules. The product rule. Logarithm of a product is the sum of a logarithms. Quotient rule. The logarithm of a quotient is the difference of a logarithms. Power rule. The logarithm of an exponential can be simplified by moving the exponent in front of the logarithm. Change of base in the formula. Allows conversations between different bases for easier calculations. How to evaluate logarithms. Example 1. Find the logarithms of a number given a base. For example, knowing how many times the base must be raised to reach a value. Example 2. Evaluate a natural logarithm with the exponent. Use the properties of the logarithms to simplify the expression. Solving logarithm equations. To solve a logarithm equation, convert it to its exponential form. This helps isolate this unknown. It's unknown and solve for the variables. Once in exponential form, solve as you would with any equation involving exponents. Applications of logarithms. Finance used to calculate growth in exponential compound interest scenarios. So we could use logarithms when in real world situations like calculating interest, calculating the growth in interest, and helping you out just finance in general. Now, another form that we can use in our day-to-day life is within physics, essentially for measuring sound, intensity, earthquakes, and magnitude. So to determine an earthquake or magnitude, you need to use logarithms, and this helps us predict earthquakes, see when they're going to come, what's the magnitude of them, and how this will affect our city. Without logarithms, we won't be able to figure these out. Now we could look at chemistry. Helps determine the pH level of solutions, which measures acidity and alkalinity. The pH level is very important. So, for example, I would say, let's say a pool, when you're going swimming, if the pH level is too high, it could cause rashes and like burns on you. So you need to make sure your pH level is at the right temperature. Also, you need to make not right temperature, right level. Also, you need to make sure the pH level is at the right level where it can kill bacteria and it's safe for you and safe to swim in that pool. Conclusion. Logarithms help solve solutions that involve exponents. We remove the different forms, keep properties, and how to evaluate and solve logarithm equations. The application of logarithms are widespread in fields like finance, science, and engineering. This can be used in your day-to-day life many times without you even realizing it. It really helps us in our day-to-day lives, and we will be struggling without logarithms if you believe it or not. Thank you for listening to my presentation, and I hope you took away as much as you could from this presentation.